As well as their obvious use in scribing circles and arcs, dividers can be used to transfer measurements from rule to work or from one place to another, to mark out lengths, and for geometric procedures used in marking out. All in all, a most useful tool. Of course, dividers have to be sharp and equal in length to be accurate. They're sprung with an adjusting nut to hold the measurement in position. To set dividers to a particular length, place one leg on a numbered mark on the rule, adjust the other leg to more than the length required, and then screw in the adjusting nut to bring the point in until it fits exactly into the required graduation. Once you've got the measurement, you can mark it along a line or scribe an arc or circle. The technique's all the same. If you've scribed a circle, it's a good idea to test the measurement. Take another rule or measure with another set of dividers and double check that the scribed circle is the measurement you wanted. Because scribing a circle will double any error. Double the radius to get the diameter will double the error, if there is one. To scribe an arc or circle, place one point in the punched mark and twist the stem while you incline the dividers in the direction of the twist so you draw the moving leg along. As well as a small pair of dividers like we've been using, you'll also need a large pair for larger measurements, which are used just the same but with a bit more pressure. Dividers are also used to draw lines parallel to one another, draw lines perpendicular to one another, bisecting an angle, and obtaining set angle measurements. To use dividers to draw a parallel line, you draw your reference line. Naturally, you'd be marking out in your workpiece, but since that won't show up very clearly on this video, we're marking out on paper using a compass, which is like dividers, except with a pencil point. Set the dividers to the distance apart the lines are to be, and then scribe 2, 3 or more arcs from the baseline. The line drawn across the top of the arcs will be parallel to the original line at the set distance. The same basic technique can be used to draw a line parallel to a curved line at a given distance, although you'll need to use a lot more arcs to follow the curve. You can either draw the curve in freehand or use a flexi curve to complete the parallel line. As well as parallel lines, you can use dividers to get a line perpendicular to a given line. If the perpendicular is in the middle of your line, then set a suitable length for your dividers. It doesn't really matter what the length is, but keep it sensible. And mark out an arc either side of the point the perpendicular line has to join the baseline. Then scribe an arc from each of these points. The point where they intersect is perpendicular to the baseline, and you can extend it out as far as you need to.
Yes, Commissioner.
If you've got to mark out a perpendicular line to the end of a line you've already marked out, then you'll have to use a bit of high school maths. Remember that right-angled triangles have 3, 4, 5 sides. Set your dividers for 3 units. Again, it doesn't really matter exactly what units. We're using centimetres this time. Mark 3 units down the line from the end of the line. Reset to 4 units. And scribe an arc out in the direction the line's going to go from the starting point. Lastly, reset to 5 units. And scribe an arc from the mark you made 3 units down the line. A line drawn from the starting point through the intersection of the 2 arcs is perpendicular. Again, extended as far as needed. All really straightforward when you know how. So is using dividers to bisect an angle. Bisecting an angle is much the same as drawing a perpendicular. Find an appropriate setting for your dividers and scribe an arc that extends over the angle. Then, from each of the intersect points, scribe out another arc. Where they intersect is the bisector of the angle. Obviously, you can get a 45-degree angle by bisecting a right angle. But once you know how to draw a 60-degree angle, you can then get 30, 15 and 75 degrees by bisecting. To draw a line at 60 degrees to another line, scribe an arc from the point where the 60-degree line has to meet the starting line. Then, scribe another arc using the same radius and from the point where the first arc cut your existing line. A line drawn from your starting point through the intersection of both curves will be at 60 degrees to the starting line. You might have recognised that as constructing an equilateral triangle. Bisecting that angle will get you 30 degrees and so on. If you have any problem understanding how to get the other angles, ask your supervisor or review the tape. Firm jointed Jenny calipers are a bit like dividers but designed to be used to mark from shoulders or edges. The firm joint allows the legs to pivot but holds them in position by friction when set. Jenny calipers are set by placing the inward curve against the end of your rule, making sure the rule is in good condition and not damaged on the end, and using your other hand to position the scriber point in the desired graduation. Both legs on the Jenny calipers must be kept even. To make the mark, hold the calipers vertical with the caliper edge close to the surface to be marked and scribe an arc. Keep the caliper leg steady. Scribe a second arc and draw a line tangential to both if necessary. Inside measurements are set with the caliper leg rotated and using a rule up against a flat surface. Transfer to the inside of the workpiece and lean in the direction of motion to scribe a parallel line with reasonable accuracy. Jenny calipers can also be used to find a centre line on a strip of metal by first opening the calipers to a little over half the width and scribing a short line from each edge. Gently tap the calipers to close them slightly and repeat. Keep repeating until the lines from both sides coincide. That's the centre line of the strip, and you can scribe it down the full length. Although centre punches are for centre marking, prick punches are for witness marking. The main difference between them is the angle to the point because of the different type of mark needed. Centre punches are used as a starting mark for drilling, where a definite mark is needed. While the scribe marking out is clearly visible at the moment, it can wear off while working. So a prick punch is used to make tiny prick marks so the scribe lines can still be followed after constant handling. Carefully roll the prick punch onto the line. Then, with a hammer large enough to make a mark, but small enough to allow you to maintain control, make your witness mark. Witness marks need to be close enough together to clearly define the outline if all other markings were removed, and would look like this when finished. Angle plates have surfaces machined square and provisions so the work can be clamped for marking out and machining. When you're marking out or machining, clamp the workpiece so the maximum amount of work can be done before you have to reclamp it. And naturally, you'll have cleaned and coated the workpiece before clamping it in the angle plate. You may even need to use parallel strips to bring it to a suitable working position. These are always marked and used in pairs and must only be used against machined surfaces. A scribing block has a machined solid base, fitted with a fixed vertical column with a clamp that allows the scribe on the column. Adjust the scriber point by loosening the clamp and gently tapping it into position. Because of that, it's really difficult to get accurate measurements with a scribing block. But a surface gauge, which you can see is just an improved version of the scribing block, has the vertical arm attached to a spring-loaded rocking bar with an adjustable screw. Once you've got the height in the approximate position, you can fine-tune it to the final measurement. Then, to scribe a line, make one clean stroke with the scriber trailing. The curved end is to make low scribe lines. A vernier height gauge is a more accurate version of the surface gauge, with a vernier scale added for more accurate measurements. There's more information about reading vernier and micrometer scales in Verniers and Micrometers, available from Caris Media Productions in Newcastle. While a bit tedious, a Trammel provides a simple way of drawing a true ellipse. Once you've got the ellipse's axes marked out, take a strip of paper. This will be your Trammel. And from one end, make a mark at half the major axis measurement. We'll call that point A. Then, from the same end, make a mark at half the minor axis measurement. We'll call that point B. Well, like I said, it'll take a little while, but with a bit of patience, you'll have a series of points that will let you complete the ellipse freehand or with a flexicurve. When you're marking out work, you mark out from reference points or lines or datum edges. All other marking out is reference from these points, lines or surfaces. This exercise is marked out from this centre line. The first step is to mark out the centre line on the plate and centre punch the centre of the circle, which is the reference point.
So you see the lines. So that the seek, I'll just get a center.
Set your dividers to 30 millimetres, half the diameter given, and scribe the circle. Reset the dividers for the 120 millimetre diameter circle, 60 millimetres, and scribe it. Then, to do the 51 millimetre wide tail, we divide it in half, set the dividers, and scribe parallel lines either side of the centre line. Then mark out the 24 millimetres measurement. Bisect the right angle to draw the key. And scribe out 5 millimetres either side. After you've finished marking it out and witness marking, the finished job should look like this and be ready to be made up. On this job, part of an offset bench vise, you'll see that the measurements are all made from the two edges. These are datum edges. After filing the two datum edges, clamp the work against an angle plate with the first datum edge resting on a parallel strip. Set the 50 millimetre measurement on a scribing block or surface gauge and scribe it. Then mark the 30 millimetres up to the centre of the circle and scribe it. And that's all the marking out that can be done in this position. So rotate to the other datum edge and clamp again. Remember to plan your marking out so you can do the maximum amount of work at each clamping position. And check before you release the work that you've made all the measurements you can. Mark out the other 30mm measurement for the centre of the circle. And finally mark the 60mm measurement for the other edge. Quite regularly, you'll need to mark out a given number of circles equally spaced around another circle of given diameter. PCD, or pitch circle diameter. For example, we're told we need 6 holes of 8mm diameter around a PCD of 250mm. Drawing the 250mm circle's easy, but since we can only mark out straight line distances with dividers, we need to know the straight line distance between each of the 6 holes, the caudal pitch. The first way to calculate caudal pitch is by calculation using the formula CP equals PCD by sine 180 divided by n, where n is the number of holes we wish to mark out. CP equals 250 by sine of 180 divided by 6, which equals 250 by sine 30, which equals 250 by 0.5, which equals 125mm. Alternatively, you can look up the measurements in tables of caudal pitches. These tables give a factor to be multiplied for a given PCD. For the same example, 250mm PCD, but with 11 holes, the caudal pitch is calculated by CP equals PCD by K, which equals 250 by 0.2817, which equals 70.43mm, which is easily marked out using dividers. Well, that's it for this section. Take some time now to practice the different skills you've seen in the video before being tested. If any part isn't clear, refer to your workbooks or supervisor or review the video.